Hello students, and a very warm welcome to all of you. Today, we're going on a journey that starts deep inside our planet, the Earth. We're going to be digging into the world of minerals and energy resources. These are the very things that build the world around us. But first, let's do a small exercise. Just pause for a moment and look around you, wherever you are. What do you see? Maybe a door handle, a water bottle, the legs of your table? How many things can you spot that are made of metal? I'm sure you can find many. But have you ever wondered, where does all this metal actually come from?
Well, the answer to that question is minerals. That's right. From something as small as a tiny pin to a huge towering building or a bridge, almost every single thing we use is made from minerals that were taken out from the Earth's crust. They really are the building blocks of our lives.
So, here's our lesson plan for today. First, we'll understand what exactly a mineral is. Then, we'll see how we can classify them into different groups. After that, we'll explore the different places where these minerals are found. We will also learn about a very important concept called an ore. And finally, we will do a quick recap, and I'll give you some useful tips for your exams. Okay, let's get started with our first topic. What is a mineral? When geologists and scientists use this word, what do they actually mean? Let's find out. Now, this is the official definition. Geologists define a mineral as a homogeneous, naturally occurring substance with a definable internal structure. I know that sounds very scientific, doesn't it? But don't worry, we're going to break it down piece by piece so it's very easy to understand. Let's break that definition down. First, what does homogeneous mean? Well, it simply means that the substance is the same all the way through. Think of a small crystal of sugar. If you break it into even smaller pieces, each piece is still sugar, right? That's homogeneous. Next, naturally occurring. This one is quite simple. It means it's made by nature, not by humans in a factory. And finally, definable internal structure. This is the most interesting part. It means the atoms inside the mineral are not just randomly thrown together. They are arranged in a very neat, orderly, and repeating pattern. This is what gives minerals their beautiful crystal shapes.
And you know, that internal structure is everything. It decides all the properties of a mineral. For example, look at a diamond. It's the hardest mineral we know because its atoms are packed together in a super strong structure, formed under great heat and pressure. And on the other hand, you have talc. It's the softest mineral. You can easily crush it into a powder. Why? Because its atoms are arranged in weak sheets that just slide apart. So you see, two different minerals with completely different properties, all because of how they were born inside the Earth.
Now that we know what a mineral is, let us move to our next section. How do we classify them? Just like we classify plants and animals in biology to study them better, geologists also group minerals into different families.
Let's look at this chart together. At the very top, you see the word minerals. Now, just follow the lines coming down. You'll see they split into three main families. We have metallic minerals, non-metallic minerals, and energy minerals. These are the three main groups we need to remember.
Let's focus on the first group, the metallic minerals. Now, this group itself is divided into two. First, we have ferrous minerals. The key word to remember here is ferrous, which is related to iron. So ferrous minerals are those that contain iron. For example, iron ore, and manganese, which are so important for making steel for our railways and buildings. The other type is non-ferrous minerals. And as the name suggests, these minerals do not contain iron. Examples include copper, which is used in all our electrical wires, bauxite, from which we get aluminium for airplanes, and of course, precious metals like gold.
The other two groups are much simpler. Non-metallic minerals, as the name tells us, do not contain metals. Think of things like mica, limestone, or even the common salt we use in our food. And finally, we have the energy minerals. These are the real powerhouses of our world. This group includes coal, petroleum, and natural gas, the fuels we use to generate electricity and run our industries and vehicles.
All right, so now we know what minerals are, and we know how to classify them. But the big question is, where do we actually find them? This is a very important part of our lesson. So, let's explore the different ways or modes of occurrence that minerals are found in nature.
So, our first stop is inside igneous and metamorphic rocks. In these rocks, minerals are often found in cracks and cavities. We call these veins and lodes. Let's see how they are formed.
I want you to imagine something. Deep inside the Earth, minerals are often in a hot, liquid, or molten form. This liquid mixture gets pushed upwards with great force, and it finds its way into any cracks or gaps in the surrounding rocks. As this liquid cools down, it solidifies, and the minerals form inside these cracks. Now, when these mineral-filled cracks are small, we call them veins, and when they are very large, we call them lodes. This is how we find many important metals like tin, copper, zinc, and lead. Now for our second location. Minerals are also found in sedimentary rocks, but here the story is a bit different. They don't form in cracks. Instead, they are found in entire beds or layers.
So how do these layers form? Well, just imagine an ancient river or sea. Over millions of years, tiny bits of minerals and rocks settle down at the bottom. This process of deposition and accumulation continues, forming layer after layer, just like a huge cake. Over a very long time, the heat and pressure from the layers above concentrates these minerals. This is how we get huge layers of coal and some types of iron ore. This also includes minerals like gypsum and potash salt, which were formed when ancient seas in hot, arid regions dried up and evaporated.
Our third method of formation is quite different from the others. This one does not happen deep underground. It happens right here on the surface of the Earth through a process called weathering.
So how does this work? Imagine a surface rock that is made up of many different materials. Over thousands of years, rain and wind continuously act on this rock. Now, some parts of the rock are soluble, meaning they can dissolve in water. These soluble parts are simply washed away. But the tougher, less soluble, and more valuable material is left behind as a residual mass. And the best example of a mineral formed this way is bauxite, which is the ore of aluminum.
And finally, let's look at two other places we find minerals. First, we have what are called placer deposits. This is when rivers flow over rocks and erode them. The running water carries away the lighter materials, but the heavier, more valuable minerals, like gold, silver, and platinum, get deposited in the sands of the valley floors. And last but not least, we have the vast oceans. The ocean water itself contains huge quantities of dissolved minerals, like common salt and magnesium. Also, on the deep ocean floor, we can find small, potato-sized lumps called manganese nodules.
Now, I've used the word ore quite a few times, like with iron ore or bauxite. This brings us to a very important question. We know that minerals are found in rocks, but do we just mine any rock that has a mineral in it? The answer is no, and this brings us to the very important concept of an ore.
So what is an ore? An ore is any rock that contains a mineral, but, and this is the important part, the mineral must be present in a high enough concentration to make it profitable to extract. Think of it like this. If you want to make a glass of juice, you need a good number of oranges, right? A single orange won't give you enough juice to make it worth the effort. It's the same with mining. A rock is only called an ore when it has enough of a valuable mineral to make all the cost and effort of mining it worthwhile.
This picture of a mine explains it perfectly. You see, any place that has minerals is called a mineral deposit. But that deposit only becomes a mine when geologists and economists decide that it is commercially viable, meaning profitable, to actually extract the ore from the ground.
Phew, we have covered a lot today, haven't we? So let's just take a moment to tie it all together with a quick recap. And after that, as promised, I'll share some tips on how to write great answers about this topic in your exams.
All right, everyone, listen carefully. This is very important from your exam point of view. If you get a question for 3 or 5 marks, for example, on the different modes of occurrence of minerals, I want you to follow these 4 steps. First, always start your answer with a clear definition of the main term. Second, state the main points or types that the question is asking for. Third, and this is very important, explain each point briefly and always try to give a correct Indian example. And fourth, end your answer with a good, clear summary sentence. If you follow this structure, your answers will be very clear and will help you score full marks. I really hope you found this explainer helpful. Thank you for learning with me today.